Welcome to our physics review. This lesson will be over motion of a simple pendulum. If you forget what a pendulum is, here's a few examples. Right here, a pendulum is basically you put what's called a bob on the end of a string, and when it swings back and forth, it gives you this nice oscillatory motion, back and forth and back and forth. So, we're going to discover in this lesson the relationship between the period of a simple pendulum and the length of the pendulum. The equation we'll use in this particular problem is the period is equal to 2 pi times the square root of the length divided by the gravity. So the problem states find the period of a simple pendulum that is 0.8 meters long. Okay, so we're not given much in this problem, but the formula doesn't require much. It simply has two variables. So long as you fill one, we'll be able to solve for the equation. So the variable that we're going to be looking for is the period. It says find the period of a simple pendulum that is 0.8 meters long. So this 0.8 meters is going to represent the length that is given right here. Okay, so all we have to do is input this value into this formula, and we'll be able to solve fairly easily. One thing I want to note real quick is, again, gravity. I've stated before that gravity is normally 9.8 meters per second squared. But in this case, for ease of calculation, again, I want to use 10 meters per second squared. Now, in my class, if you want to use this, I just ask that you note this on your page, and feel free to use gravity as 10 meters per second squared. Okay, so let's begin to solve for this problem. It's, like I said, it's a pretty easy problem. So the period is equal to 2 pi times the square root of the length, which is 0.80, divided by gravity, which is 10. Okay, so all we have to do is actually type this on our calculator, and so I'll do that real quick. And after I've typed in on my calculator, the period of oscillation comes out to be 1.78 seconds. Okay, and I told you this was a simple problem. That is our final answer, and that concludes this problem.